Let's study 10th standard ICSE chemistry, chapter 8, Organic Chemistry, Alkanes, Alkenes and Alkynes. Organic chemistry is the chemistry of specific carbon compounds. In fact, all compounds having carbon are called to be organic, except oxides, that is carbon dioxide and carbon monoxide, carbonates, carbides. All the remaining carbon containing compounds are organic, and that constitutes 90% of all the known compounds to us. So it is a huge branch and a very vital branch of chemistry. Now, out of all these carbon compounds, we have a class of compounds called hydrocarbons. As the name suggests, they have hydrogen and carbon only. So all the compounds which have only carbon and hydrogen are called hydrocarbons. And in this chapter, we will focus mostly on hydrocarbons. Example, methane, ethane, ethene, ethyne. How will we name different compounds and remember them? Well, we have to follow certain rules which we shall study in this chapter. Note, all hydrocarbons are organic. The reason why these compounds are called organic is because they are mostly found or were initially discovered in living things. Inorganic chemistry deals with the remaining 10% of compounds and minerals. For example, all the metals, the salts, etc. Even acids and bases. So, carbonic acid is inorganic. Even though it has carbon, it is a carbonate after all. But why is carbon so unique and special? Truly, all life on Earth depends on carbon. It's impossible to imagine life on Earth without carbon. You see, all the vital compounds in our body, like carbohydrates, proteins, fats, all are carbon-based compounds. So there are three reasons why carbon is unique out of all the elements in the periodic table. First, tetravalency. Carbon has 4 valence electrons, so its valency is 4. So it can form 4 covalent bonds. That gives it ample opportunity to form a variety of compounds. The second property is quite interesting. It's called catenation, which is a very rare property. Apart from carbon, it is also seen in elements like silicon, but catenation is mostly seen in carbon. It is the tendency of an element to form chains of identical atoms. That is, it is a property of elements by virtue of which atoms of the element can link to each other in the form of chains of identical atoms. That is, a long chain or ring structure can be formed. So imagine a straight chain where carbon is linked to carbon, which is linked to another carbon, and this can go on, theoretically, to infinity. And we can have additional atoms connected here, which could also be carbon or hydrogen or some other element. And there are so many ways in which these chains can be formed. This is an example of a branched chain, where this is the primary chain, the longest chain, and here's a branch. We can even have closed chains, if we start from here and it ends here. Notice that each carbon atom can have exactly 4 bonds. That is a very important point to be kept in mind while drawing structural diagrams like this. So carbon, a double bond with this carbon, single bond with this carbon, and one more bond is left here, so probably there will be a hydrogen out here. So this self-linking property is called catenation. Because of catenation and tetravalency, we can have either carbon-carbon single bond, or carbon-carbon double bond, or even carbon-carbon triple bond. Quadruple bond is not possible between 2 carbon atoms. This dash or hyphen simply means that we have one more bond left because 4 valencies of carbon have to be satisfied. So probably there is a hydrogen out here and a hydrogen out here. Now that is a proper compound. So if there are only single bonds in the compound, in the hydrocarbon, it belongs to a family called alkanes. If we have even one double bond between carbon-carbon, it belongs to a family called alkenes. And if there is a triple bond visible, then the compound belongs to a family of alkynes. More about this shortly. Another interesting property about carbon compounds is that there are many isomers possible for the organic compounds. Isomers means same molecular formula but different structural formula. This is different from isotopes or allotropes. Isomerism is visible in organic chemistry abundantly. We will study this with examples shortly. Now the difference between organic and inorganic compounds is listed here. Organic compounds are made up of these particular elements, whereas inorganic compounds are made up of all the elements in the periodic table. In organic compounds we have covalent bonds, whereas inorganic compounds have ionic compounds. Organic compounds have low melting and boiling points, whereas inorganic compounds have high. Organic compounds are insoluble in water but soluble in other organic solvents. Like dissolves like. Inorganic compounds are usually soluble in water but insoluble in organic solvents. There are exceptions, of course. Organic compounds are non-conductors of electricity, whereas inorganic ones are good conductors. Organic compounds are combustible. In fact, the components of petroleum, natural gas, LPG, all fossil fuels have organic compounds, except coal, which is mostly pure carbon, and pure carbon is considered to be inorganic substance. Organic compounds are volatile, so they have low boiling point, hence they can evaporate very easily. Inorganic compounds are usually non-combustible and non-volatile. They show catenation and isomerism, they don't. So organic compounds can be classified as aliphatic, that is open chain compounds, which could be either straight chain or branched chain, or they could be cyclic, closed chain compounds, like this one. In our syllabus, we only have aliphatic hydrocarbons, which may be alkanes, alkenes, or alkynes. Cyclic or closed chain is not in syllabus, but we should know one example at least. Let's say benzene, that is C6H6. How is that formed? Well, it has 6 carbon atoms. Alternatively, it has double and single bonds, and we have 6 hydrogen atoms as well. So do practice that diagram as well, benzene. But we don't have to study any other properties of cyclic compounds in our syllabus. Now alkanes, if you remember, have carbon-carbon single bond. Alkenes have carbon-carbon double bond, and alkynes have carbon-carbon triple bond. Out of these, alkanes are called saturated, whereas alkenes and alkynes are called unsaturated. I'll explain that soon. But before that, let's understand the definition of homologous series. It's a series of organic compounds where the successive members follow regular structural pattern and the successive compounds differing by CH2. Let's understand this with the help of an example. Here, alkanes. Look at the last name, anes. So ethane, propane, and butane, signifying that there is no double carbon-carbon double bond or carbon-carbon triple bond here. So if we start with ethane, we have 2 carbon atoms with single bond, and the remaining valencies of the carbon are satisfied by hydrogen atoms. So this is called the branched or expanded structural formula. We can condense it and write like this. This is called condensed structural formula. Carbon-carbon, single bond, and just write H3, H3. It's understood that the bond between carbon and hydrogen is a single bond. No need to show that because hydrogen's valency is always just 1. So it can't be a double bond or triple bond anyway. And the molecular formula is C2H6. 2 carbon atoms and 6 hydrogen atoms. Let's go one step ahead. Next in the family, we have 3 carbon atoms. Single bonds, of course. And then fill in the blanks with the hydrogen atoms. Remember, each carbon atom should have only 4 bonds. So this carbon atom already has 1 bond with carbon. 3 bonds are left. So hydrogen, hydrogen, hydrogen. Same way here, hydrogen, hydrogen, hydrogen. But the middle carbon atom has 2 bonds already with carbon-carbon. So it has 2 valencies left. So please draw only 2 hydrogen atoms linked to this one, because a carbon atom cannot have more than 4 bonds. This is the branched or expanded form. So if they ask you to draw structural formula, usually that means they want the expanded form. The condensed form is carbon bond, single bond, again single bond. This one has 3 hydrogen atoms, this one has 2, and this one has 3 hydrogen atoms. Notice that this single bond is not between this hydrogen and carbon, okay? It's between the carbon and the carbon. It's understood because hydrogen is attached to the carbon and no need to show that bond. We know it's a single bond. Molecular formula, 3 carbon atoms, 8 hydrogen atoms. So C3H8, propane. Same way, if we have 4 carbon atoms, it is called butane. Ane means single bond everywhere between carbon-carbon. So this is a family of alkanes. It is a homologous series because they have the same basic general formula, structural formula, and each member, subsequent member, differs by CH2. C2H6 plus CH2 gives you C3H18, H8, plus CH2 gives you C4H10, plus CH2 will give you pentane, which is C5H12, and so on. So that's a family of alkanes. So you should know at least the first 10 members of this family. The first member is methane. Yes, not ethane, but methane, which starts with just 1 carbon atom. So we have just 1 carbon atom, hydrogen, 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 hydrogen. Yeah, there is no carbon-carbon single bond visible here, but still it's a part of this family. Remember, 1 carbon is meth, 2 carbons eth, 3 is prop, 4 is but, and then it becomes easier to remember. 5 is pent, hex, hept, oct, non, and dec. And the ane simply means it belongs to the alkane family. So you can think of this like a surname to identify which family it belongs to. Now I have a task for you. Why don't you grab a pen and a paper and just try to draw the expanded form of C10H22. See if you get it. I'll give you a hint. C10. So first draw 10 carbon atoms. Draw hydrogen later. First the 10 carbon atoms in a straight line, one after the other, single bonds. And then fill in the blanks with all the hydrogen atoms around it. Let's see if you are able to get it. Another interesting thing is if you calculate the molecular weight, it always differs by 14. That's because it differs by CH2, and CH2 is totally 14. That's why. Another interesting thing is that there is a general formula for this family called CnH2n plus 2. So if I want the 7th member of the family, just substitute n as 7. So it will become C7 H2 into 7 plus 2. How much is that? 2 into 7 is 14 plus 2 is 16. So C7H16 is heptane. Let's check. Here we go. C7H16. So this formula is so useful. We can find the formula of any member of the family. This is a homologous series. We have many such homologous series. We have alkenes, alkynes, alcohols, aldehydes, carboxylic acids, ketones, ethers, esters, etc. So we'll be studying all of these in a while. Coming back to homologous series, there are some characteristics as I've explained. In any homologous series, or simply speaking in every family, same elements and functional group are there. Functional group is the identity of a family. For example, what is the identity of alkanes? Carbon-carbon single bond. So that's called a functional group. General formula? Yes, the general formula here is CnH2n plus 2. All of them obey the same general formula. Chemical properties are all same because they have the same functional group. Molecular weight differs by 14 as you go down a series because CH2 is 14. And physical properties also show gradual gradation. As the molecular weight increases, the boiling point and solubility also changes. But what is the importance of studying homologous series? Well, if we have families, it's so easy to systematically study its properties. It's like in the periodic table, you have group 1 as alkali metals or group 17 as halogens. So why do we have these families? Or in biology, we have kingdoms and phyla. Classification always makes it easy to organize the knowledge and remember it and make predictions about the next members of the same family. Remember, all the hydrocarbons we are studying in this chapter are aliphatic, that is, they are open-chained and they are organic. Now let's look at the next homologous series, alkenes. As I said, its identity is carbon-carbon double bond. So let's look at the structural formula of some alkenes. Let's start with eth. Eth, prop, and but. Eth means 2 carbon atoms, prop means 3 carbon atoms, but means 4 carbon atoms. 5 carbon atoms would be called pent, of course. And ene is the surname because all of them have carbon-carbon double bond. So how to draw the structural formula? Well, we have 2 carbon atoms, so double bond here. And hydrogen, it's easy to find out how many hydrogen atoms will be there because each carbon atom can have only 4 bonds. So double bond here, so single, single here, and single, single here. 4 bonds, check. 1, 2, 3, 4. Yes, perfect. So the formula is C2H4. The IUPAC name is ethene. IUPAC is International Union of Pure and Applied Chemistry. That's the international body to decide the names of these compounds so that in all countries, scientists will use the same name to avoid any confusion. There is a common name for it. It's called ethylene. So you should be aware of these common names also. Next we have propene. So we need a carbon-carbon double bond, but there are 3 carbon atoms. Well, we need just 1 double bond anywhere. It could be here or here. Doesn't matter. It's the same thing. And then fill in the blanks with hydrogen. So this carbon atom will have 3 hydrogen atoms attached to it. This one will have just 1 hydrogen atom because it's a single bond here and a double bond here. So 3 bonds already satisfied, and this is the 4th bond. And this carbon atom, well, we've got double bond here, so 2 hydrogen atoms here. You could have drawn it straight as well. It doesn't matter. So the molecular formula is C3H6. That's propene for you. What if the double bond would have been here and single bond would have been here? Well, it would just be a mirror image of this, so it would actually be the same compound. It would still be propene. Next we have butene. Common name is butylene. So we have carbon, 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 4 carbon atoms. Everywhere single bond, but we need a double bond. That's why it's called ene, because it has 1 double bond. Can it have 2 double bonds? Yes, but such compounds are not in our syllabus. So let's stick to just 1 double bond. And then you have to decide, after writing the root chain, decide how many hydrogen atoms will be connected to each carbon atom. Be careful, a carbon atom should have only 4 bonds. And the formula comes out to be C4H8. Now, butene is a little interesting because what if we would have drawn this double bond out here and a single bond here? Then this carbon atom would have had only 2 hydrogen atoms and this one would have had 3 hydrogen atoms. But the formula would have been the same, and in fact it would be just a mirror image. However, what if the double bond was in between here and single bond here and here? Now that would be a totally different compound. So if you look at page 248, we see isomerism. Now let's dive deep into this topic called isomerism. I said that this is a property in which the molecular formula is same, but the structural formula is different. So this is the same as the formula we studied on the previous pages, where the double bond is here, which could have been here as well, same thing. And here we have the double bond in the center. The molecular formula is same, but here notice we have CH3 here and CH2 here, but here we have CH3 and here also we have CH3, and in between we have CH. If you draw the expanded form of this, you will see that still each carbon atom has 4 bonds only. So this is also valid, and this is called butene. But it will have slightly different properties, so it's a different compound. So they should be named differently. So according to the rules of IUPAC, what we will do is, first write down the structural formula. Next, number the carbon atoms. 1, 2, 3, 4. We could have started from left hand side also. 1, 2, 3, 4 of the longest chain. Here it's just single chain, so no confusion there. We'll have to start from the right hand side for this compound because we should always start numbering with the carbon atom closest to the functional group. What is the functional group? It's the identity of that compound. Yes. So we'll start numbering from here because the carbon atom should get the lowest number, which is closer to the functional group. We can't start from the left hand side for this particular compound. And then this number will be written here, 1-butene. No need to leave space. No need to write capital letter either. We can also write it as but-1-ene. The hyphen is compulsory. Okay, no comma here. This is exactly how you should write. What if the double bond would have been drawn here? Well, then we would have started numbering it from here. 1, 2, 3, 4. And still the name would have been 1-butene. It's just a mirror image. But here, the naming is different. Let's start from RHS. 1, 2, 3, 4. We could have started from LHS also 1, 2, 3, 4 because either way, the second carbon atom would be having a double bond, which is what we want. The double bond carbon atom should have as low a number as possible. So 1, 2, 3, 4. Where is the double bond? At number 2. Don't write number 3. We want a lower number. So 2-butene. So in exam, perhaps they would give you 2-butene and ask you to draw it. So you have to break it up. First of all, but means 4 carbon atoms. 1, 2, 3, 4. Next, ene. Ene means double bond. And number 2 means it should be at the second carbon atom, between second and third. Not between second and first. If it was between second and first, we would have called it 1-butene. So now you know the difference between 1-butene and 2-butene. They are isomers. Same molecular formula, but different structural formula. They are called position isomers because the position of the double bond is different. Position of the functional group is different. But that's not all. We have one more isomer for butene. What if, instead of writing all 4 carbons in a straight chain, we write it like this. 1, 2, 3, and the 4th one is attached to the middle carbon. So it's called a branched chain. Then put a double bond here, or we could have done it here also, or here, doesn't matter. And then fill in the blanks with the remaining hydrogen atoms, such that each carbon atom satisfies 4 bonds. Now how to name this? We'll come to that shortly. Things get interesting now. By the way, this is called chain isomer. This is a position isomer because only the position is changing. This is a chain isomer because it's a branched chain now. So coming back to the homologous series of alkenes, we have ethene, propene, butene, pentene, hexene, heptene, and so on. Interestingly, we don't have methane. For alkanes, we started with methane, but for alkenes, we are not starting with methane, we are starting with ethene. Why? Why do we start with 2 carbon atoms? Why not 1 carbon atom? Well, what's the definition of alkenes? The identity of alkenes? Double bond. Carbon-carbon, double bond. Now, if there is just 1 carbon atom, how will we have a double bond? It's not possible. Hence, for alkenes, we start with ethene. And now the third important homologous series is alkynes. Yep, it has a carbon-carbon triple bond, so it will have just one hydrogen here, C2H2. It's also called acetylene. Propane, well, it's carbon-carbon-carbon, 3 carbon atoms in a straight chain. Put a triple bond somewhere, either here or here, doesn't matter, it's the same thing. And hydrogen atoms, of course, formula is C3H4. And then we have butane, carbon-carbon-carbon-carbon. Put a triple bond here or here, and put the hydrogen atoms, we get C4H6. But again, what if the triple bond is in the center? Then it will be an isomer. Let's look into it. By the way, butane is called ethyl acetylene. This is not so important. Propane is called methyl acetylene. This has to be learned, yeah. And what about the general formulae? Well, if you notice, for alkenes, the general formula is CnH2n. That means whatever is the number of carbon atoms, the hydrogen atoms are always double of that. And for alkynes, the general formula is CnH2n minus 2. So again, I have a task for you. Can you tell me the molecular formula of the 7th alkyne? Pause the video and figure it out. 7th one. So it will be C7. Are you ready? Can I tell the answer? And H2n, that is 2 into 7, 14, minus 2, 12. So the formula is C7H12. That would be called heptine. So again, coming back to the summary. For this chapter, these 2 pages of summary, that is 247 and 248, are very important, and you need to practice all the formulae with the names of these 2 pages. Not only the equations, but even these formulae are important. So here we have butane. We call it 1-butane because the triple bond is for carbon atom number 1. We can say carbon atom number 2 also, but we should always give a lower number, right? Yes, we can call it but1-ine also. I prefer 1-butane. IUPAC allows both. But what if the triple bond is in between? Then the formula changes. The molecular formula is same, but the structural formula is different. That's a position isomer. Now let's go for the next one. Pentyne. Pentine. Okay, how do we draw pentine? Pent, 5 carbon atoms, please. 1, 2, 3, 4, 5. Ine, triple bond, please. Triple bond. Now, hydrogen atoms, let's see. 3 valencies satisfied, 1 is left, put a hydrogen here. This one, carbon 3 satisfied here, 1 bond here, all 4 bonds done. No hydrogen, no hydrogen. Here, 2 hydrogen atoms. If you want to draw the expanded form, of course, you'll put a dash here and put hydrogen, and here dash and put a hydrogen here. That's how you do the expanded form. This is the condensed form, which is fine as of now. Again, here 2 hydrogen atoms and here 3 hydrogen atoms. What's the formula then? 1, 2, C5H8. 3, 5, 6, 7, 8. Yes, I used the general formula. I didn't count the hydrogen atoms. So that's 1 pentyne because the triple bond is for carbon number 1. But what if it was for carbon number 2, that is between 2 and 3? Then we would call it 2 pentyne. So the structural formula differs and properties would also be slightly different. And we have something called a branched chain as well. So we have 1, 2, 3, 4 carbon atoms in a straight line, but the fifth one is a branch attached to this one. How do I name such a thing? It's a chain isomer of pentyne. Well, there are some rules provided by Iupac which we shall learn shortly. Fortunately, alcohols is not in your syllabus. You don't even have carboxylic acids. So before we start learning the Iupac the rules, let's study a few more basic terms. Now, there's a new group called alkyl groups. Whatever parent alkane we have, like methane, ethane, propane, butane, if I remove one of the hydrogen atoms from it, it becomes the alkyl group of it. Methyl, ethyl, propyl, butyl. Of course, they can't exist independently because one valency is still not satisfied. So something will have to stick out here. Maybe a chloride or a fluoride or an OH. Then it can be called methyl alcohol or methyl chloride or methyl fluoride. But whenever you see "-yl", it simply means that it is an alkyl group, that is an alkane from which one hydrogen atom has been removed. So when you come across such examples in the future, you will see what it is all about. Next, what is a functional group? I told you in simple language, functional group is the identity of a compound. That is any atom, radical or a bond which defines the structure of the organic compounds and confers the characteristic properties to it is called a functional group. For example, there are many functional groups, but you just have to learn these ones. If you have a compound with OH, hydroxyl group, it belongs to a family called alcohols. So this OH is the identity of alcohols. This OH is the functional group. This is called methanol, by the way, and this is called ethanol or ethyl alcohol. Why? Well, first of all, there are 2 carbon atoms, so that's eth. Okay, and we don't have any double or single or triple bonds, so it's ethane, not ethene or ethyne. And we have OH, that's a functional group of alcohols, so we add all, so that's ethanol. This was in detail in your chapter, but it's no longer in your reduced syllabus, so you just have to know a few examples, that's all. Aldehydic group is CHO. Just remember this. Whenever you see CHO in any compound, it's an aldehyde. And the surname for this family is -al. So that this will be methanol. Why methane? Because it is 1 carbon atom. Yeah, the common name is formaldehyde, by the way. This one is called ethanol. -al means it's an aldehyde. That is CHO is a functional group. And why eth? 2 carbon atoms, that's why. By the way, its common name is acetaldehyde. In the next lecture, when you will mark all the answers of the exercise and solve the various questions of Iupac nomenclature and diagrams, at that time you'll get the hang of all these names and all these structures. So give it time, you will find it easier after some practice. Next, if you find a functional group called COOH, then it belongs to a family called carboxylic acids, and this functional group is called carboxylic. So in exam, they can give you a formula and ask you to name and identify the functional group. So identify this and name it as carboxylic group. The name of the compound is methanoic acid. 1 carbon atom, so methane. And whenever you see COOH, it's oic acid always. Common name is formic acid. Another example is ethanoic acid. Common name is acetic acid, yeah. It's used in vinegar. And why ethanoic? Because 2 carbon atoms, that's why. I know this carbon is in the functional group, but even that has to be counted. What about the next member in this family, like propanoic acid, butanoic acid? Yeah, they have the same rules. But mostly in exam, they don't ask higher compounds, they ask the lower compounds. Next, what if to that alkyl group some halide is attached, like chloride, bromide, fluoride, iodide? Such a functional group is called halide. So this is called chloromethane. Yep, here the functional group name came first. That's the rule. This is only for halides, okay? Chloro and methane. Why methane? Because 1 carbon atom, that's why. Common name is methyl chloride. But in exam, if they ask Iupac name, please write only this. Otherwise, in any answer, you can write either name, that's fine. And in IUPAC name, no need to leave space. You can write it as one word. And hyphens are only between numbers and letters, or letters and numbers. What is this C2H5Br? Well, that's ethyl bromide. So that's ethyl bromide. But IUPAC name will be bromoethane. Bromoethane. So that's how we name it. What if a compound has more than one functional group? Like it has bromide as well as COOH both. Well, that means you are studying the wrong textbook. Maybe a 12th standard textbook. Because in 10th standard you don't have such complicated compounds. Now let's talk about isomers. As I said, it's organic compounds with same molecular formula but different molecular arrangement or structural formula. So they have similar chemical properties but they differ in their physical properties. And the number of isomers increases with the increase in number of carbon atoms. That means, see, ethene and propene don't have any isomers. Butene has isomers. Pentene has even more isomers. So higher the compound, more the number of isomers. This is butane. It has 2 isomers. Yeah. Pentane has 3 isomers and so on. This is cancelled. Isomerism is of 2 types. Either it's a chain isomerism or it's a position isomerism. Chain isomerism means that there is some branching, and position isomerism means the bond or that functional group is in a different position. This is cancelled. Let's take a few examples. Let's talk about butane. Butane. But means 4 carbon atoms and ane means single bond. That's C4H10. This is a normal butane. But what if we arrange the 4 carbon atoms like this? 1, 2, 3 carbon atoms and the 4th one out here. And then put the hydrogen atoms. So this one will have only 1 hydrogen atom because 1 bond, 1 bond, 1 bond, 3 bonds are done. So the 4th bond will be hydrogen atom. And yet the formula of this is same, C4H10. So even this is butane. But structurally it's different. Its physical properties will be very different. Melting point, boiling point. Commonly it's called isobutane. But what about the IUPAC name? Let's see how to name it with the rules of IUPAC. This is butane. That's it. No numbering here. Here the rule says, number 1, identify the longest chain. So this is the longest chain. Okay. 1, 2, 3 carbon atoms. So this is called the parent alkane. 3 carbon atoms means pent. No, that's 5. What is 3 carbon atoms? Right, prop. It's prop. And single bond, so ane, propane. So this is a propane, fine. And this is some additional attachment to this carbon atom, a side branch. What is this, by the way? It's CH3. Does it ring a bell? CH3. CH3 is methyl, isn't it? It's a derivative of methane. So this is called a methyl group, which is attached to this carbon atom. So its name is methyl propane. Yes, methyl propane. It is an isomer of butane, but its IUPAC name is methyl propane. But this methyl is attached to which carbon atom? We'll have to do some numbering here. So numbering is only for the main chain, the longest chain. So let's start from here. 1, 2, 3. So it is attached to the second carbon atom. So its name, ladies and gentlemen, is 2-methyl propane. No need for the space and put a hyphen definitely. If you put a space, no problem, no marks will be cut. But without hyphen, you'll get a 0. So this is just one example of naming. We'll have to do dozens of such examples to be thoroughly trained in naming compounds. And believe me, after some time, you will find it quite interesting. It's like a riddle. So it's 2-methyl propane. What if we would have started numbering from left-hand side? Well, would it make a difference? 1, 2, 3. So it will still be attached to number 2, right? And remember the rule, the lower the number, the better. Let's talk about pentane now. So we've got 3 isomers of pentane. We've got a straight chain here, we've got a straight chain with 1 branch, and another straight chain with 2 branches. And notice, still we have 5 carbon atoms only, and still we have 12 hydrogen atoms only. So the formula is the same, molecular formula. It is a pentane called neopentane. But what is the IUPAC name? Wow, this is challenging. This, try it, pause the video and try it. Okay, ready? So it's 1, 2, 3, 4. So that's butane. At number 2 we have methyl. So it's 2-methyl butane. That's the name. Yep, here it is. Oh, you looked, here is it. Now without looking here, hide this and try it out here. First of all, the longest chain. Let's take this as the longest chain. 3 carbon atoms. Okay, 3 carbon atoms is propane. Yeah, propane. And we have 2 branches, methyl and methyl, on carbon number 2. So that's 2, comma 2. No hyphen between 2 numbers. Please put a comma here. 2, comma 2. hyphen dimethyl propane. Why di? Because there are two methyls here. That's why. That's how we write it. Okay, tell me, what if I would have taken this as the longest chain, the main chain? Because even this is 3 carbon atoms. Well, it won't make a difference. Still, I will have a methyl group here and a methyl group here. So I would still name it as 2,2 dimethyl propane. The common name is neopentane. You have to practice all this formulae with the names. It's time consuming, but devote your time now and master it so that later you find it easy during exams. Now let's go for alkenes. Remember in the summary we had left the branched naming, so let's do it now. We know what is 1 butene and 2 butene, they are position isomers. But what about this branched chain? How do we name this? Well, we've got double bond here. So this is the longest chain. 3 carbon atoms. What is that root name? Propene. Prop because 3 carbon atoms and double bond, so ene. And this is a branch attached at the side. It's methyl at carbon number 2. So it's called 2-methyl propene. Notice that here I would definitely start numbering from the left hand side. 1, 2, 3. You know why? Because the double bond is on the left hand side. So I would always want the double bond to get the lowest number. Maybe it wouldn't make a difference in this particular case, but remember this rule. So it's 2-methyl propene. By the way, it's still an isomer of butene, okay? It's just the name is 2-methyl propene. What if we would have taken this as the longest chain? Yeah, it can be L-shaped as well. It's 1, 2, 3 carbon atoms. No, in this case it won't be allowed because I want the functional group of double bond to be a part of the longest chain. So it had to be this one. Although, if you notice here, I could have taken this as the longest chain, 1, 2, 3, 4, that is butane. And this could have been considered as an attachment at number 2 carbon atom. So it would still be called 2-methyl butane. If you wish, you can watch this video twice, as many times as you want to. You just have to watch it and you'll understand slowly. Geometrical isomers are cancelled, that's a relief. Now, alkynes. Well, we have studied 1-butane and 2-butane, pentane also 1 and 2. They are position isomers. Branched isomers, that is chain isomers, are possible even here, but it won't come in exam. For alkynes, no, it won't come. So what is nomenclature? It is a system of assignment of names to organic compounds. And why do we need nomenclature? Well, there are a large number of organic compounds, millions of compounds. If we don't have a systematic naming pattern, it will lead to confusion. There are so many isomers, so only if we have the correct naming with the correct numbering will scientists agree about anything. And there are two systems. One is a trivial system, which is the common names, which is useless because the names may change from country to country. The Iupac system is internationally recognized. All this is cancelled simply because it's a repetition. That's why. Iupac full form. And according to this system, every compound has one and only one name. Two different scientists of two different countries won't disagree on the naming because they would follow the same rules. And the rules are, number 1, get the root word first of all. Number of carbon atoms in a linear chain. Meth, eth, prop, but, pent, etc. Step number 2, the primary suffix. Suffix means which comes at the end, means after meth. Should I write ane, ene, ine, what? Well, it depends on the carbon-carbon bond. Ane, ene, and ine. Secondary suffix means apart from this, we may add one more suffix in the end, like all, oic acid. Cancel this, please, because this is not a suffix, it's a prefix. Like methanol, methanol, methanoic acid. That's how. It depends on the functional group. And finally, prefix. Prefix is something which comes before the name. So either you can have di, tri, tetra, for example, dimethyl or trimethyl or trichloro. Or if it is a halide name, we will write it in the beginning always. Bromoethane, chloroethane. And when we write the ethyl, methyl names, while naming, we will go in alphabetical order. What does that mean? We will take an example shortly. So now let's practice our naming skills. So this is the compound. How will you name it? First, step number 1, longest chain. I guess this one. 5. How about this one? No, that's just 4, so it won't work out. Not even this. So longest chain is this one. 5. Okay, so that's pent. Great. And I see only single bonds, so pentane. Great. 1, 2, 3, 4, 5, pentane. And I see a methyl group. So methyl pentane. Methyl pentane. Why methyl? Because only one carbon atom here. It's a branched chain here. And it is at number 3, carbon number 3. So 1, 2, 3. Oh, it could be 1, 2, 3. So the answer is 3-methyl pentane. Did you get it right? Okay, try this one now. Without looking at the answer, try this one. First of all, the longest chain, 1, 2, 3, 4. So that's butane. Butane, fine, butane. Single bond butane. This is a methyl group, so it will be methyl butane, methyl butane. But I have to give numbering. So should I start numbering from the right hand side or the left hand side? Well, try to give a lower number to this methyl group, please. So let's start from the right hand side. 1, 2. So 2 numbering would be better rather than 1, 2, 3. No, avoid that. So 2. So 2-methyl butane is the answer. Don't leave a space. Not necessary, but hyphen is necessary here. Okay, what about this one? Can you guess it? Don't look at the answer, please. This is a bit challenging. We've got 2 attachments here. We've got a methyl group as well as an alcoholic group. So the parent chain, this is the longest chain here. 1, 2, 3, 4, 5. That's pentane. Yeah, single bond. So pentane. Pentane, okay. Methyl is always a prefix, so that will come in the beginning. So methyl pentane. And this is all. It's a functional group OH, so it's all. That is a suffix, so that will come in the end. So that's pentanol. So it is methyl pentanol. Methyl pentanol. But numbering is now important. Because if I tell you methyl pentanol, how would you know on which carbon atom is this OH? You could have drawn OH here also or here also. And how do you know where is a methyl attached? Here or here or here? That is why numbering is important. But who should get a lower number? OH or CH3? Well, if there's a competition, always go for the OH. So you will never get 2 functional groups, but you can get one of these functional groups and one of the alkyl groups. So whenever there is a competition between an alkyl group and a functional group, lower number goes to the functional group. So the numbering is 1, 2, 3, 4, 5. So that's 4-methyl 2-pentanol. They wrote pentane 2 all, but I write -2-pentanol. Or you can write like this, it's fine. 4-methyl 2-pentanol. Wow, that was an interesting sum. Now let's go for this one. I've got 2 halides here. Halogens attached are called halides now. The longest chain will be pentane. Okay, pentane, single bond. And it will be bromo-chloro or chloro-bromo. And how will the numbering work out? Who should get a lower number? What is the rule? Well, for halides, the rule is they're always named as well as numbered alphabetically. That means bromo will always get the smaller number and will be written first. Remember this: bromo, chloro, iodo, fluoro. It's all alphabetically for halogens. Okay, so let's start the numbering from left hand side so that the bromo gets the smaller number. So it'll be 2-bromo-4-chloro pentane. Please practice all this and send me the pics as homework. Don't just copy it. This is the last chapter. Come on. I'm burning the midnight oil right now. You should be willing to too. Now this one. This is very, very interesting. Think about it. Don't look at the answer, please. 1, 2, 3, 4, 5, 6, 7. That's a heptane. We could have done this also, right? This is also longest chain. Let's count. 1, 2, 3, 4, 5, 6. Remember, there is 2 carbon atoms here. So it could have been C-C also. But 6 is still small. So let's go for 7. Heptane. Single bond heptane. I've got 2 attachments here. A methyl group and an ethyl group here. Methyl group, ethyl group. Okay, methyl and ethyl. So who should get the lower number and what should be written first? Now look, remember this rule. The smaller alkyl gets minimum number. So methyl should get the smaller number. So let's start from the left hand side. 1, 2, 3. If you start from the right hand side, 1, 2, 3, 4, 5, then methyl is getting a bigger number than ethyl. But the rule says smaller alkyl gets minimum number. So start from left hand side numbering. 1, 2, 3. So it will be 3 methyl and 4 ethyl. 3 methyl, 4 ethyl heptane. But while writing it, it is alphabetically. That's why I wrote here. While naming, alphabetical order. So ethyl will come first, E comes first, N comes second. That's it. These are the rules. You have to use only these many rules. Yes, it's something new for you, but the more you practice, the more you'll get the hang of it. So let's test your knowledge now. Come on, tell me the name of this. Carbon, carbon, that's eth, double bond, so ene. chloro and chloro. So that's dichloro, 1 and 2 number. So 1, 2 dichloroethene. That's one word. And this should be hyphen out here. Don't forget. And comma between numbers. Okay, what about this name? Eth, ane, single bond, bromo, 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 bromo. So that's tetrabromo. And numbering 1, 1, 2, 2. So that's 1, 1, 2, 2 tetrabromo ethane. There should be hyphen between number and letter. Why should we write all these numbers? Well, there are 4 attachments, so we have to give a number for each attachment compulsorily. Okay, we put a comma out here, but here we didn't put a comma. We wrote 2 bromo separately and 4 chloro separately. Why? Well, because it's bromo and chloro are different. Here they are the same, bromo. All are bromo. Hence we can just club them together. Okay, what about this one? Try it on your own, please. Don't just copy. 1, 2, 3, 4, 5. That's pent. And this is a double bond. So that's ene, pentene. Methyl group is attached at number 3. Should we start from left hand side or right hand side? Left hand side, of course, because I want the double bond for the smaller number. If I start from here, 1, 2, 3, double bond will get number 3. No, I don't want that. So the naming is 3-methyl, 2-pentene. Did you forget this too? You can't ignore it. Because this double bond could have been anywhere. It could have been here also. So you have to write the number for the double bond also, for pentene at least. So 3-methyl, 2-pentene or pent-2-ene. Okay, this one. Well, which would be the longest chain? This one has 3 carbon atoms. So this is the longest chain, yeah. That's propane, single bond propane. This is an attachment, this is an attachment. Numbering 1, 2, 3. It could have been 1, 2, 3 also. So methyl is also at number 2. Iodo is also at number 2. So the name is, can you guess? It's 2-iodo, 2-methyl propane. 2-iodo, 2-methyl propane. Yep, iodo will have to be written first. It's a halogen. Come on, halogen versus alkyl group. Always the functional groups win. It's like the rules of rock, paper, scissors, isn't it? Now let's do the reverse. Come on, take your pen. 2-chloro, 3-methyl, but-2-ene. Draw the diagram for this without looking at the answer, step by step. 2-chloro, 3-methyl, but-2-ene. First, look at the root word, but. But means 4 carbon atoms. Ene means double bond. At number 2. So there's so much information in this. Okay, so but means 4 carbon atoms. Ene means double bond at carbon number 2. That is between 2 and 3, of course. Next, they are saying 3-methyl and 2-chloro. So at the third carbon atom, put a methyl group. And at the second carbon atom, put a chloro group. And now fill in the blanks with the hydrogen. So this has 3 valencies left, so 3 hydrogen atoms. This one will have no hydrogen atom. Already 4 valencies are satisfied. This one satisfied, 1, 2, 3, 4. This one will have 3 hydrogen atoms. Yes. That's the answer. And there you get 1 mark. So now this page 226, this table is a very good way to summarize everything we've learned so far. It'll be a good page for you to revise from during exams. So we've got all the homologous series at one glance. We've got alkanes, whose general formula is this. They're also called paraffins. Some of the structural formulas are also given, condensed. Functional group, not really. It's carbon-carbon single bond, but we can't really call it a functional group. It's something ordinary. Root words, meth, eth, prop, but, of course, and the primary suffix or the surname is ane. They don't have secondary suffix. Iupac names and trivial names are also given, which is the same in this case. Alkenes, the general formula, they are also called olefins. The functional group is carbon-carbon double bond. The surname is ene. And these are the Iupac names. Notice how there are isomers, 1 butane and 2 butane. Remember that their formulae, structural formulae are different. Look here. You have to practice all this if you haven't already. If you've done something, no need to repeat it. Otherwise, please practice all of this. Then we have alkynes. This is the general formula, the molecular formulae, and the structural formulae. Functional group is carbon-carbon triple bond. The surname is ine, and these are the common names of them. Alcohols. Well, I remember it with a general formula called ROH, where R is this CnH2n plus 1. R is nothing but an alkyl group. Methyl, ethyl, propyl, butyl, these are all alkyl groups. Just add one OH to it, it becomes an alcohol. Methyl, alcohol. Ethyl, alcohol. Propyl, alcohol. These are the common names, what I just said. But of course, the Iupac names will be methanol, ethanol, propanol. Why one propanol? Well, here in the diagram, I'm putting OH for the first carbon atom. What if we would have put this OH to the second carbon atom? So this will become just H, and here it will become H3. The molecular formula still would have been the same, but now the structural formula and the physical properties will be different. So we would now call it 2-propanol or propan-2-ol. What is the functional group here? It's called OH. It's called hydroxyl, or you can call it alcoholic. Next we have aldehydes. So I like to remember it like RCHO. You take any R that is alkyl group and just add one CHO to it. For example, you take methyl and add CHO. Ethyl, add CHO. Propyl, add CHO. Or you can just take hydrogen and add CHO to it. What is the name of the first one? Methanol. Why methanol? Because one carbon atom. Yeah. Here we have 2 carbon atoms. Totally we have 2 carbon atoms. So call it ethanol, please. And then we have propanol, butanol. No numbering here. We can't have CHO attached in between. It won't be possible. It has to be at the end only. So chain isomerism is not possible in aldehydes. And these are the common names. Please learn them as well. Even for carboxylic acids, we can't have chain isomers. No numbering here for aldehydes and carboxylic acids. So what's a carboxylic acid, by the way? Well, just take an R that is an alkyl group or even an H and stick a COOH to it. That's the functional group. That's the identity of it. COOH. Everywhere COOH. That's the functional group. If they ask you to draw the functional group, please show this whole diagram. Just don't write COOH. Show C double bond O and single bond OH. It's called carboxylic group, or you can even write carboxyl. And the namings, of course, you have to learn methanoic acid, ethanoic acid, and propanoic acid. How propanoic? Well, 1, 2, 3 carbon atoms. So propanoic acid. And please learn the common names. Something strange here. This is propanoic acid, and the common name is propionic acid. So be careful about this. Alkyl halides. Yeah, take an alkyl group like methyl, ethyl, and add one halogen to it. So what would this be called? Chloromethane, bromoethane. No numbering required here, because if I would have written Br to this carbon atom, it's just a mirror image. It will still be called bromoethane. Yeah, for propane, butane, isomers are possible. What are the common names, by the way? Common names are methyl chloride, ethyl bromide. Pretty easy. Ketones, ethers are cancelled. Page 247, 248, summary, which I've explained, has to be practiced for now. So with this, we finish the major chunk of this chapter, the homologous series, the formulae, the isomers. We stop here. The rest of the chapter will be done in another class. The rest of the chapter is simply quite theoretical and some chemical equations. It's pretty easy comparatively. Just the chemical properties of these substances and some give reasons. Nothing major.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.